All right, so we are going to now switch to types of volcanoes. The type of volcano largely depends on either the type of magma, so either the mafic or the felsic magma, as well as how much gas is kind of trapped in the liquid, if you will. So first, we're just going to start at volcano locations. You can see that they're mostly around subduction zones. This is the Ring of Fire. This is where the Pacific Ocean is all subducting around the edge of that. And if they're not at subduction zones, they're still largely at continental plate boundaries. There are a few exceptions, like Hawaii here. So the first time they're going to talk, first kind they are talking about is the continental fissure eruptions. This is where the crust, so it could be either the continent or the ocean, is being pulled apart, and as it thins, it doesn't have as much pressure to hold the mantle back, and so the mantle ultimately can rise up to the surface. This is not like it's going to happen like with one earthquake and then there's a crack in the ground and lava starts coming up. This is over thousands and thousands or millions of years of pulling until it gets weak enough it just can't really hold it back. So this is your mid-ocean ridge and your rifting on continents. And it's not really going to be like that dangerous, I guess, of an eruption. Not a lot of gas here. So it just kind of comes out and just flows on the surface. And when it does that, you get these really thick layers of basalt here. I mean, tall. I've seen the one at Mammoth Lakes in California, and we were talking maybe 20 feet high of just basalt wall. And that's not one of the major ones. It's not even listed here. So it's got the Columbia Plateau as an example where you can see this isn't currently happening, but you can go and see this large basalt here from these fissure eruptions, and then other locations, India, Brazil, and Siberia. Then there are hotspots. These are the ones that are not on the edge of a continental boundary. And so you can see here in black, they have the continental boundaries. And then the red, we have the hotspots. So in America, we're looking at Yellowstone and Hawaii. I guess these might be American too. I don't know. And these are not nearly as famous. I have not heard of them before, looking at this book here. But as you can see, there's actually quite a few in the Pacific Ocean. The source is mantle plume. I think I already mentioned we're not exactly sure what causes this. The predominant theory is a bump on the Earth's core. If you remember, it goes like crust, and then like the mantle, and then like in the center is the core. And so they think maybe there's a bump on the core, and that kind of pushes the magma up. If that's the case, I think there's a lot of kinks that still need to be worked out in that theory, but it's the best one we have right now. There we go. And these are, well, the ones in Hawaii. This is not true about Yellowstone. So the Hawaii hotspot is a shield volcano. And that is because it is that mafic kind of magma. The rock type is basalt here. So it just flows. It's not sticky at all. It just kind of flows and oozes. But unlike the rifting one where it just kind of forms a plateau, it forms a very, very broad hill. But if you look at it, it doesn't really have that traditional volcano shape. And that's because it just flows and oozes so far out. And these are actually like the largest volcanoes in the world. Let's see. Yeah, that's about it. Low viscosity. There we go. Cinder cones. A lot of times this is also more of that mafic material, but when you get a little bit of gas. And so it just kind of shoots up instead of just flowing out. It does shoot up a little bit, but then it just kind of rains down. And this is also where you aren't going to be in a whole lot of danger from this kind of eruption because it just kind of falls right back down in place. And this does kind of make these little volcano shapes, but they're not very large. They're still very small. And then depending on, it cools and turns into rock quickly because it's being thrown out and cooling off. And depending on the size of what's coming out and what's cooling, we have different names. So we have bombs, which are more rock type or rock size. Ash would be real more fine grained, and blocks would be like boulders falling down. And then they give the example of this volcano in Mexico, also called a scoria cone. Composite volcanoes. These are associated with subduction zones. They are the most common type of volcano, and these are that traditional, like if you're in second grade and you're going to draw a picture of a volcano, this is what you're going to draw. And it has different layers of like a pyroclastic layer where things kind of came up and shut down and fell down, and that's what gives it that height. But then it has layers of more of that basaltic magma that kind of glues everything together, if you will. So if you go back to this, you can see these loose materials piled up. They don't really have a lot of cohesiveness to them, so they don't really stick together. So they weather really easily. They can roll away, wind, water, right? That's partly why they're so small. But here, when you get that height, and then the next time it erupts, it's that mafic material that flows and covers and hardens to rock kind of uniformly. It kind of glues everything in place, so it's not really weathering, and you get that really, really tall volcano look, like you would think of Mount St. Helens. And then you can have these little lava domes. These usually form, or I know them more commonly forming in the crater like this is shown. You see this at like Crater Lake, where there was an explosion or an eruption and the top exploded off, so it leaves this crater. And then as the magma chamber starts to kind of refill, you'll get these little it'll start rising up, and then you can get little eruptions. You can get these little lava domes. Silica. So again, the pyroclastic here would be the silica eruptions alternating with the more mafic, the iron heavy eruptions. And again, these are mostly associated with subduction zones, because if you remember at the subduction zone, you get the melting of the crust as well as some of the ocean material that's being subducted down. And then here is just a little size comparison of the different types. And so you have Hawaii, that shield volcano. So it's very huge, but very broad. It's not like just this like pointy triangle sticking up. And then you have Mount Shasta, which is a composite volcano. So it's kind of more of that triangle, but in comparison, really pretty small. And then the cinder cones are just tiny little things. And